Okay, so welcome back. This is part 6 in our series where we show you how to convert your Arduino into an oscilloscope. And you can see the application we're developing here. And it's got a lot of functionality. We're going to talk about in this video some of the core functionality and how to implement that in our programming language. And we're going to be using C#, but as I mentioned before, we've gone through in the previous videos the design concepts and block diagrams and everything, so you should be able to do this in just about any software application, but we're going to use C#. Now what we're going to talk about is how to do the C# programming to do the basic functionality of the scope. And as you can see here, the basic functionality is that we're communicating with our Arduino over the USB port. And so we're going to have some functionality to identify and open the port and also close the port. And the user is going to enter some data, how many samples in each scan. And you can see the scans are being refreshed here. It turns out it's about 5 or 10 times every second. We're having a very fast refresh rate. So we're going to enter how many samples in each scan. And also the Arduino VREF, which we talked about before. If you're not familiar, I encourage you to look at the previous videos. The user can set high-speed mode or not. We talked about that in previous videos. And in this video, I'm going to show how to write the C# code to do the ports and to communicate with the Arduino. And basically, this application is going to request data from the Arduino, grab that data, process it, and then plot it. And we're going to be updating that every, 10 times a second or 5 times a second or whatever. So that's going to be the core functionality that we're going to look at in this video. So as we showed in the previous design videos, this is a basic block diagram of how this is all going to work. And in our previous video, we did the Arduino code. And in this video, we're going to look at the computer side of things and figure out how to do this in C#. As we mentioned before, we're basically sending a request that looks like B100, which says, give me a burst of 100 milliseconds worth of data. We send that over the USB to the Arduino. It grabs the data, puts it in an array of values from 0 to 1023, and sends it back to the computer. And in this application, we're going to have these simple blocks that show the functions of our C# application. So as you can see, we're going to have to open a COM port. We're going to send a request on a regular basis to the Arduino for data. And then when we get the data back from the Arduino, we're going to have to read that COM port. And then we're going to have to process that data because we're going to be getting values from 0 to 1023 out of the analog to digital converter. We have to put that back into volts that represent what was coming into the analog input. So we basically read the data, process it, and then we plot it on the screen of the oscilloscope. And then after some delay, and this is an important part we talked about in previous videos, after some delay, we're going to have to send another request. When everything is all done and we're ready, we send the next request to get more data, and then we keep going through this loop and refreshing the oscilloscope screen. So basically, our functionality in this C# application is going to be dealing with a COM port, sending a request, reading the data, processing and plotting, and then doing that over and over again. Now, some of the lessons we learned in the previous videos that we're going to have to implement here, we decided we're going to sample and transfer only the voltages, not the times for each sample. That's going to save us a lot of RAM on the Arduino. And then we're going to generate the time steps in our C# application. Since we know what the scan time is going to be and how many samples, we can generate time steps. We also decided we're going to use a baud rate of 2 million. We talked about that in the previous video. We set up the Arduino for a high-speed baud rate on the USB. And then we're going to have to figure out actual elapsed times for each part of the process. As you can see in our application, I've got this debug mode where we're printing out in our text box how long it's taking for different parts of the process. So the total scan plus plot time is 30-something milliseconds. We're adding a buffer time, kind of a safety margin between scans of 50 milliseconds, which gives us a total interval of about 80 milliseconds. So we want to implement that in our C# so we get some feedback on how long everything's taking. And then as we mentioned, we're going to add this buffer time between refreshes, just as a safety margin. And then we also talked about the C# application and the Arduino need to agree on this Vref value. And if you're not familiar with that, I encourage you to look at my previous videos. I did a video on USB voltages and Arduino accuracy where we talk a lot about that. And then we're also, this is very important, we're going to make sure that we don't allow the user to request a scan time that's less than the time it takes to process the samples. Because we said, you know, in the default configuration of the Arduino, it takes about 0.1 millisecond to do a sample. So for 500 samples, it's going to take 50 milliseconds. So we don't want to request a scan time that's like 10 milliseconds because it's going to take a lot longer than that to process all the samples. So we've got to be wary of that when we write our C# application. So these are the things we need to remember when we're writing the application. And at the end, the goal is really, the main functionality of this application, the Arduino is going to have an array of integers that it grabs from the analog input, and it's going to be an array of values from 0 to 1023, right? And that's going to represent the 0 to 5 or whatever voltage coming into the analog input. It's going to send us that array, and we have to convert that into an array of doubles, which for each sample is a time and voltage value. So that's the big goal here, is to take the data from the Arduino, convert it into time and voltage values. And once we have that, we can do all kinds of processing and plotting, and everything's easy. But this is going to be the main goal of our application. So here is kind of a functional diagram of the components in our C# application that we're going to need to implement. And it's just a general idea. It's going to give us an idea of, for example, what classes we need and what functions or methods we need. So over here, I've got my main Windows Forms application. We're going to do this in Windows Forms. So our main UI application is going to be very simple. It's just going to initialize variables. It's going to set up the UI, set up the chart, and set up the COM port. So it's going to be basically setting it up, and then it's going to be transferring the operation over to a timer. So keep in mind that this is basically, once we tell it to start grabbing data, there's going to be no more user input for the most part. It's just going to be a system timer that's going to be sending requests to the Arduino to grab data, and this application is going to be processing it, and we're going to be out of the loop pretty much. So the system timer is going to be the main worker in all of this, and it's going to be sending requests, and then this application is going to be receiving and processing the data. Now the next step is we're going to have a lot of COM port stuff we're going to have to deal with. For example, if I start up my application, there's nothing happening. However, it has already set up these text boxes. It's given default values, and if you can see down here, it has gone out and searched for any active COM ports that were found. And it's found two. It's found on COM4, one called USB serial port, and the other is COM8, where there's an Arduino Mega. So you can see here we've got some initial starting functionality that goes out and searches for stuff before we've even done anything. So we're going to implement that in our code so that the user knows, you know, what COM port is available and which one to open. So there's going to be some COM port. We find the active COM port, open the COM port, and then read data from the COM port, and of course close it. Now you can put that in a class. We're not going to do that, but you can get the idea. It's kind of a functional class that does COM port stuff. So once we send a request, we're going to read data from the Arduino, and then the next thing is we're going to go into another class that we call the Input Data Processor class. And that makes a lot of sense. You're basically going to get a string of data, an array string of data of maybe 500 samples or whatever from the Arduino, and we're going to pass that array of data into this Input Data Processor class, and its job is to convert the 0 to 1023 values into voltages. And again, we're also going to generate a time scale because there's no time data coming from the Arduino we talked about previously. It's just going to be volts. So we have to use some logic to figure out what time value to assign to each voltage value. Okay, so we wanted a time and voltage array of data that we can operate on. So it's going to generate that time scale and put those into this double array of time and voltage. Once we've got that, we can do a maximum, we can do an average value, we can do a bunch of analysis of this data for each scan, but this is the really important part. We got to generate that double array. And once we've got that double array of time and values, we can just send that out to plot, and it will be very straightforward. So that's kind of the basic functionality. We're going to have an input data processor class, we're going to have a system timer, we're going to have the main UI that sets everything up. We may or may not have a comport class, but you can see we've got the basic functionality. One other thing we're going to implement a debugger functionality. And you can see here, I've got a checkbox where I can select debug, and it will give us feedback on how long different parts of the process are taking. That's going to be very, very important to make sure that all the timing is right and we're not stepping on toes and making requests before things are finished and that kind of thing. So this debug mode is going to be very, very important. Okay, so now let's take a look at the C# code that we've developed based on the previous discussion of functionality. This is a simple Windows Forms application in C#, and as you can imagine from the previous discussions, it's fairly simple to implement. I have here basically three functional blocks that we're going to talk about. Right here is my main form 1, where I'm basically doing some initializing, setting up my form, and I've got a bunch of methods. And what's going to drive this whole application is an event handler, a couple of the event handlers, right? So these are the important parts of the application. This second part I have is a separate class that I've defined as the input data processor class. And we've discussed this before, and as you can imagine, it's fairly simple. We're going to get the data from the Arduino in our main form, and that data is going to be sent into this input data processor class for parsing, converting the input string array from the Arduino into integers. And it's also going to figure out what the time values are. It's going to reconstruct the time values for each sample. And ultimately, as we mentioned, it's going to come out with a double array, which is time, comma, value, where the times are in milliseconds and the values are in volts. And once we've got that double array of times and values, we can then go through and process it in this application or in this class, where we can calculate the max, the minimum, the average, we can figure out the frequency, and we can do all of that in this input data processor class. And also, once we've got that array, we can then send that array to our plotting function to plot the chart. So pretty straightforward functionality here. The other thing is the obvious form design. And you can see here we've got a bunch of buttons that are going to be, we're going to have event handlers for the buttons. We've got some text boxes that we're going to have some default values and also allow the user to enter values for the text boxes. We've got an output debug text box that gives us some feedback on what's going on. We've got some track bars that are going to have some real-time update of this display. And we also have to set up the chart and that kind of thing. So that's the basic functionality of this application. So now let's step through our main Form 1 part of the application and see what we got here. We'll start with the using statements, using system, of course, and then system collections.generic, because we're going to be doing some lists. System.data, I forget what that's for. System.drawing, we're going to be, of course, doing some colors in the UI controls. So we're going to need system.drawing. System.link, language integrated query, we're going to be using for going out and looking for the comport descriptions. We're going to need that. Of course, system.windows.forms. And then we're going to need system.management for the descriptions of the COM ports. So as we showed before, it's not just the COM port numbers we're going to display, but also a text description of what each COM port is. So we're going to need system.management for that. System.io.ports, of course, for the serial port. And then system.io we're going to need because we're going to be writing a CSV file, so we're going to need that. And then, of course, system Windows Forms Data Visualization.charting, because the chart is going to be a big part of this. And then lastly, we're going to need system.diagnostics because our debug stopwatch will require this diagnostics. So not a lot of using statements, pretty straightforward. Now, the main Windows Forms application, as usual, I have it, we're using regions to break everything down into blocks so they're easy to understand. And also, as usual, I've got documentation as one region, my to-do list, which right now is pretty much empty. I've got my initializing, where we initialize the variables, my form 1, and then a bunch of methods, and then my event handlers, okay? So let's take a look at what we've got here. Documentation. As I mentioned before, I think documentation is crucial in any software development. So I put in a lot of documentation. It helps me to figure out, if you come back after a month or so and say, how did that work? Documentation is really beneficial. So I'm not going to go read this for you. You can, if you want to read it, you can pause the video and read through. I'll just scroll through some of the stuff. It talks about the dynamic buffer time, where we have a safety buffer between scans. It describes the high-speed mode we've talked about previously. We set up the Arduino for high-speed analog read. The baud rate that we're going to be using is a high value. The time values we talk about, we don't gather the time values from the Arduino. We generate them here in this application. Bandwidth. We explain how the time of the analog read affects the bandwidth and what the actual numbers are going to be. And then we talk about the samples and the sample rates, depending on the memory limitation of the Arduino. If you use a Mega, you have a lot more memory, so you can get higher number of samples and that kind of thing. And then I've got just a general description of this application, what it does, how it does it. It makes a note that you need to first enter the VREF value for the Arduino to make sure you're using the right analog digital conversion. And then we talk about the flow of the application. It starts with the trigger or start button. What that does, it sends a command to the Arduino. And then there's a timer event. This application starts a timer, and the event handler calls the read Arduino burst method, which we'll talk about, and basically it explains how all of this works. So that's my general documentation. I like to also keep a to-do list of things that need to be done. Like I say, it's pretty much everything's done. And then we go into the application itself. And it starts out, as you can imagine, by initializing a bunch of variables. So, of course, the first thing we're going to have to do is set up the COM port. So I'm using the system.io.ports, and I am defining a serial port, and I'm going to call it Arduino port. I'm also defining a public variable. It's a double called vref, which is the 5 point whatever volts we're going to use. That is what the Arduino uses for vref. We've got a baud rate. We've got a number of samples per scan. We're defaulting at 500, but as we mentioned before, the user can input that value and can also input the vref. And then we've got scan time buffer milliseconds, and this is a value between scans. It's kind of a safety margin, so we're setting that as a default of 50. Then we're going to have some values to configure the oscilloscope. We're setting the y-axis maximum. We're defining if we're going to use DC coupling. That's going to be a Boolean, which tells the application whether we want DC or AC coupling. And then we've got the single shot button up here, which basically takes a snapshot of the waveform and it toggles, and it's going to use this Boolean to determine if the button is clicked or not. We'll talk about that. Some of the features, by the way, in this application are going to be in the next video where we get in depth about the detailed features. Again, here we're just going to talk about the basic functionality. We've also got some variables. As we get the data from the Arduino, we're going to get an end command from the Arduino, and when we get that, we can set this Boolean that says, okay, we received the data. This next one is very important. It's the burst duration in milliseconds, which is how many milliseconds is going to take for each scan. We're going to use that a lot. It's going to be very, very important to get our timing accurate. And actually, this is going to be a dynamic value. As the user changes the scan time that's going to be displayed, we're going to update that burst duration milliseconds. So it's going to be a very big player in our application. And then we're going to get this, as we mentioned, a list of string from the Arduino, and we're going to call it raw input string list. And that's basically the array, the string array from the Arduino with all the data that we're going to have to parse. We're going to send into this input data processor and parse it. And then milliseconds per sample, we're defaulting that to 0.1. Again, we talked previously about how we can set up the Arduino to do a high-speed read, where this is going to be like 0.02, but we're going to default it at 0.1. And then we've got a simple debug Boolean. When you click this debug checkbox, it's going to define if the user wants to have some debug info sent out to this text box for some feedback. And then we've got a stopwatch, system diagnostic stopwatch that's going to use to help us figure out how long each step of the process takes, and then we're going to feed that back to this output text box. And then the last thing is we're going to have a list of doubles. We're going to have two lists of doubles, which are the X and Y values for each sample that are going to be sent to the plot routine. So these are going to be in milliseconds, and then the Y values are going to be in volts. So that's basically our initializing, pretty straightforward. The main form, when I open up the application, is going to be basically these four methods. I like to keep this form one very, very simple and clean and just have it do some setup. So let's start up the application, and I'll show you when you start up the application, this is what you're going to get after it goes through this main form one, okay? So you can see it's going to do the default initialize component to set up the form. And then we're going to have a UI setup method that sets up the UI and kind of inputs a default value of 8 for the COM port and number of samples per scan and what the default VREF is. And also a chart setup, which sets up the colors of the chart. And then, of course, the port UI setup, which sets up the port. And as you can see, as I start the application, it gives us a default value of the port, and it allows you to open the port. And there's also a close port button that is invisible here because you can't close the port if you haven't opened it. So we start out by making that invisible. But also, it goes out and it searches for any active COM ports in this port UI setup, and it returns into this text box what are the available COM ports, and it also gives a description. Then the user can look at the available COM ports and their description and say, okay, COM8, I've got an Arduino Mega, so I enter COM8 and hit this open port. So that's basically what this is doing. It's basically setting up the UI, setting up the chart, and setting up the ports. And these methods are located here in this methods section. So you can see those three methods are the first three methods in my methods section. Once you've got that set up, and we'll go through these, but once you've got that set up, of course, this port UI setup is going to call a method that gets the ports and returns them in a list of string. And that's basically all of the setup stuff. And then after that, it's going to rely on the user to click the open port button, which we'll call this open port. And then we're going to set up a timer, which is going to do all of the reading. Let's take a look at the methods that we're going to use, these first four methods, to set everything up. So the first thing is UI setup. And as you can imagine, all it's doing is it's setting up the text box with the default values. It's setting up our AC or DC coupling radio button with a default of DC coupling selected. And then it's going to set up the horizontal and vertical track bars. These track bars, it's going to set those up. And we'll talk about those in a future video. But basically, it's going to set up some defaults of the track bars. And here's the horizontal time track bar, and here's the vertical track bar. And it's just going to set up defaults. And then it's going to pre-configure some UI buttons to be disabled and invisible until they're relevant. Like the start button or the trigger button, we're going to disable that until you pick a port and open the port. And then the close port, like we said, is going to be invisible until you've actually opened the port. So pretty straightforward. You're just setting up the UI and getting everything ready. The next one is chart setup. So as you can imagine, the chart setup can be easy or complicated, however you want to make it. What I've done is I have put into code the different setup values for the chart. You can do it however you want. I've basically said I'm using the default chart and the default series 1. And the chart type, I'm setting series chart type.line. It's a basic line chart. And I'm changing the width of the chart, of the display, the waveform line, to a width of 2 to make it a little bit more visible. Unfortunately, with Windows Forms, that is a chart series border width. It's not line width, it's border width, but there you go. And I've set up the color for the series, so it'll be a yellow trace. And then here I'm just setting up the X and Y axis, minimum, maximum, the interval, and I'm also setting up a feature of the X-axis to round the values to make them a little bit cleaner. And then I've got a title, I've got the color of the grid lines. The grid lines are going to be gray. I've set the line width to 1. Again, you can go through and do this however you want. I also set the back color to black, which gives you a black background. And then I cleared all the legends as I start, just to make sure everything's all cleared out. And then I have added a default value to the points on that series, since it start out with a 0, 0. You may not need that. The other important thing I'm doing, and you don't have to do that, but I chose to do that, is to use data binding. And I'm binding the XY values of this chart to the string that we talked about, the list of string that has the X values and Y values. So as I update the X and Y values, it will bind that data to the chart and update the chart. So that's basically the chart setup, very straightforward. You can do it however you want. So we've done the UI setup, the chart setup, and now it's the port UI setup. What we are doing is we are appending the text in this text box down here, and that's text serial data.append text, and it says the following active COM ports were found, and then it goes out and gets the available ports, returns it as a list of string, and then appends that list of string to that text box. And it calls the getPorts method, which returns a list of string, and we're going to call it port list. And down here is our getPorts method, and it returns a list of string. So now the getPorts method, this is where we're going to use the system.management to get the COM port descriptions, not just the COM names like COM4 or COM8. This will also give us the description of each port. And as you can see, it'll tell you if you've got a mega connected to your COM port. So you can go through and just copy this. I am using the management object searcher, and this is why we need the link. We have to do a select from, and this is kind of counterintuitive, but you can go through and use this, and it basically gets the port names and puts that into a string array, and then it gets the description. Right, so it uses the serial port get port names, which returns a string of port names from the system.io.ports, and then we're going to use this searcher, and you have to go through all of this, but it basically ends up giving you a list of string with the descriptions of those port descriptions, and then it returns that port list. So this is unfortunately the code you need to use to get that. So if you want that, you can just pause and take a look. So now we've done everything to set up, and now we're going to wait for the user to start pressing buttons. So then it's going to be when he presses an open port button, it's going to call this, and it's going to read the burst of data from the Arduino. It's going to process that by sending it to this input data processor, and then it's going to plot it. Okay, so we'll go through these in a little bit of detail later, but that's basically the flow of this application. So now, once we've got everything set up, if we look at our form, you can see that the rest of this is going to be event handlers. And we've got 1, 2, 3, 4, 5 buttons that are each going to have event handlers. So we've got 5 button event handlers to open and close the port, start the scanning, exit, and then do a single shot. We've also got these track bars. We've got 2 track bars, and as you scroll those, they're going to generate event handlers every time you move those. So that's 2 more. So now we got 7. We also have a coupling, AC or DC, so you can change the coupling on the fly. So that's going to be 2 more event handlers. And then the debug mode, we can select that, and on the fly, as this is running, you select that, and then it will start to give you the debug information, the elapsed times. So when we look at the event handlers, we know we're going to have like 5 buttons, a couple track bars, some radio buttons. Basically, that's going to be it, but there's going to be a lot of event handlers for these user interface. So here is the event handlers. As we mentioned, we've got the open port button click. We've got the trigger button click, which is also this start button. I haven't renamed it, but it's the start button. So the start button click. Then we've got, as we said, the 2 track bars, which is the horizontal and the vertical track bar scroll events. And then the radio buttons for AC or DC coupling, one event handler for each. Then we've got the all-important timer1.tick. And if you look on our UI, down here we've got this timer that we drag and dropped. Go into the toolbox and go down to timer and just drag and drop that onto this form. And this is our main system timer. Okay, we call it timer 1. And this is going to drive this display update. Okay. So this timer is going to be very, very, very important. This is going to drive everything. Here is the button where we tell the application if we want single shot or not. And then obviously at the end, we're going to close the port and we have the button exit click. All right. So let's take a look at the event handlers. And again, we're only going to focus on the core functionality, and we're going to save some of these for the next videos. So everything's all set up. The user enters the COM port number, and here is what is going to happen when the user clicks on this open port. It basically just calls the open port method. Very, very simple. So what's the open port method? We go up here, and here is the code for opening the port. And we've got Arduino port equals new serial port. We're instantiating a new serial port. We're setting the baud rate as the baud rate. And you can, as we mentioned before in the initialization, we've set it to 2 million. So we've set the baud rate, and then we set the port name to a string called com plus whatever the user has put into this text box, textcom.text, right? Whatever is in this text box. So now we're all set. We know what the Arduino port is going to be, and then we do a try catch. We try to open the Arduino port, and if it fails, then it will go into this catch, and we'll bring up a message box that says, dude, seriously, you need to plug in the device first. So if you've tried to open it and you can't open that port, it's going to give you a message and then return, okay? However, if it's successful and the Arduino port is open, then we're just going to do some cleanup on the UI to say, oh, okay, the port is now open, so I'm going to have the text behind this port open to say, okay, we've successfully opened the port, and just type port open. I'm changing some colors. You don't need to do that. I'm also disabling that open port button since it's already open. And I am enabling and making visible the close port button. All right. Now that it's open, now you need to enable and make visible this close port. So pretty straightforward. And then also the trigger, I'm enabling this trigger or start button, which was invisible and disabled until I got the port open. So that's basically it for the open port. So now we've opened the port. What's the next step? Well, here's our application. We started up. Everything's all set up. It's told us what the COM ports are available and what their description is. So I say, okay, I've got a Mega on COM 8. So I hit the open port, which we just discussed. It now shows port open and allows you to close the port. And now it's waiting for us to input data. How many samples per scan do we want? We'll leave it at 500. Our Arduino VREF 5.2. We're going to select high speed mode because this Mega has been programmed to use a high speed. And now what's going to happen is I'm going to click on this start button. And this start or trigger button is going to start the scanning. And you can see now it's getting data from the Arduino and it's plotting that. And now I can go to AC coupling and it will do that. And I can select the debug method and it's saying, okay, every 0.2 of a second it's updating this display. So the flow is once I've opened the port, the user puts in the data and I hit the start button. So this start or trigger button is going to be the next step in the process. So let's go down to the start or trigger button, which is the next one in line. And this is what gets everything going. So here's our trigger button. What we're doing is we're saying, okay, grab the data that the user has input into the sample, the number of samples text box, all right, whatever this number is, and convert to int32, and that's our number of samples that we're going to use. The next one is a simple if statement. If the user has checked that high speed mode checkbox down here, then the milliseconds per sample is about 0.02 milliseconds. It's actually a little bit lower, but we'll talk about this later, but this is the time for an analog read. If not, then the Arduino is programmed as a default and it takes about 0.1 millisecond per sample. So it's now filling in the milliseconds per sample. And now it takes that number of samples that the user wants and is sending to the Arduino an S command we talked about before. It just does an Arduino port.writeLine S and concatenates the number of samples, in our case 500s. So it's going to send an S500 and the Arduino is going to see that and say, oh, number of samples is going to be 500. And we talked about that in the previous video when we did the Arduino code. So now we're going to set the this label, the LBL scan time. We're going to set the text in that, and it's going to tell us what the scan time in seconds is set by the user. So it's going to give us feedback on the setting. So to do that, we say the label scantime.text, and we're converting to a string. And what we're using, we're taking the number of samples that the user specified, and the milliseconds per sample, whether you're in high speed or normal speed. The minimum scan time is going to be number of samples times millisecond per sample. And it's very important that we don't allow the user to specify a scan time that's less than that, because, you know, if you've got 500 samples and 0.1 milliseconds per sample, you multiply that out, it's going to take 50 milliseconds to get all those samples. And if you request something less than that, you're going to be in trouble. So we're going to set the number of samples times the milliseconds per sample, and then take the track bar value and multiply it times that. So the user can adjust that, but the minimum of that track bar is going to be a value of 1, because we don't want it to be less than number of samples times millisecond per sample. All right, so now we're setting the feedback to the user on what the scan time is going to be. And then we can configure the y-axis of the chart. Remember we said we've got this y-axis max. And the way we're going to do it is we're going to convert the track bar value. And in this case, it goes from a value of 1 up to 20, where 20 is the full 5 volts. So basically, if it's 20 times 0.5, that gives us a multiplier of 1 for the y-axis max. And then we're going to set the y-axis maximum. Now that we know the values from the user, we can tell the Arduino what we want in terms of a burst for each scan. So we're calculating the burst duration in milliseconds, and again, it's the number of samples times how many milliseconds per sample times this track bar scan time, all right? So it's going to be a minimum of 1, and that's going to give us the burst duration in milliseconds. I've set the maximum up to 10, so this value can be as much as 10. You can set it whatever you want, but it's important that you don't go below 1. You need to have the number of samples times milliseconds per sample as the minimum. So once we've got that burst duration milliseconds, and we take the vref that the user entered in this vref text box, we calculate the vref by taking the text vref.text, convert to double, and that's our vref. So then we can send to the Arduino our B command with our burst duration in milliseconds converted to a string, and that's this value here. So here's what the user requested: Arduino, send us a burst with that burst duration in millisecond. And then, once we've sent that, we're going to call this read Arduino burst, which is going to wait for this data to come back from the Arduino. So if we sent, 100 milliseconds, it's going to be B100. So we're going to wait to get 100 milliseconds worth of data. Now, once we do this, again, this is the start button. So it's going to read a burst, and it's also going to set our system timer enable to true, which starts the continuous sampling of the data. And the interval, and this is very, very important, the interval is going to be set at the burst duration milliseconds, right, which is the total time for the scan, plus our scan time buffer in milliseconds that we looked at before. Remember, we've got our scan time buffer in milliseconds. We're using 50 milliseconds. You can change that if you want. I find that to work pretty well. So the timer interval is going to be the burst duration milliseconds plus the scan time buffer. So again, this is just the start, and we're going to have to repeat this each trigger time. We're going to repeat this. Okay, so now that we have the system timer enabled, down here at the end of the start button, timer 1 enabled equals true, and we've set the interval. Now what's going to happen is this application is going to run based on the timer 1. So let's go down to the event handler for the timer 1, and this is going to refresh the display. So here is the timer 1, and as you can imagine, it's going to do a lot of what we just did. It's going to update the timer interval to make sure that we're refreshing it at the correct rate. It's going to figure out what the track bar values that the user is setting, and any other event handlers are going to affect this timer 1. The timer 1, if the check markers is checked, and this is a checkbox up here where we can apply markers to the display, and we'll talk about that a little bit later, but it's just if the user wants to show markers each scan, then this is where you can set that. So if that checkbox called check markers is checked, then we're going to set the series chart marker style, and I set it to marker style.circle. Do whatever you want, and I set the marker color to color.red. Else, we set the marker style to marker style.none. All right, so that's just for the markers. Next, we're going to set the chart maximum and minimum range, because that's going to change based on what the track bar does. And we're going to set the y-axis maximum equals 0.5 times the track vertical scale, which goes from 1 to 20, as I recall. And then we're going to set the label associated with that as scale x equals 0.2 times y-axis maximum. So if it's 5 volts, it's going to be a 1, 0.2 times 5 volts. And then we're going to set the axis maximum and minimum to what we calculate as the y-axis maximum, and the minus to the minus y-axis maximum. So it'll be, for a scale of 1, it will go -5 to 5. All right? Now, the scan time, we're going to be doing the same as we did with the trigger. We set up the label for the scan time track bar, this label down here. We're going to repeat what we did before. The scan time.text, number of samples times millisecond per sample, times the track scan value, and we're going to set that scan time.text. Then we're going to do like we did before. We send the to the Arduino the B plus the burst duration milliseconds to the Arduino, and then we're going to read the Arduino burst just like we did before. Now I've also added a stopwatch called stopwatch Arduino burst, and what I'm doing is I'm restarting that to make sure it starts at time 0. I'm starting that stopwatch when I call the Arduino burst method, which goes out and reads the data and does all the parsing, calls this input data processor to parse. And then when it's all done, I'm going to stop that, and that will give us an elapsed time to do the entire read, scan, and process. And then I'm calculating the burst time is stopwatch Arduino burst.elapsed milliseconds. So it's going to be the entire time it takes to do this read Arduino burst. And next we'll go and look at what that read Arduino burst does. Then what we're going to do is dynamically set the timer 1 interval based on the latest time it took to do that entire process. So that burst time that we just calculated, the time to do that whole process, we're going to set the interval equal to that plus our buffer, our scan time buffer. So we're dynamically updating this interval of the timer. And the last thing I've got here in the timer 1 is the, if I've got debug checked, it's now going to send out to this text box here, it's going to give the debug data. And it's going to set text serial text. Total scan plus plot time is this burst time that we just calculated in milliseconds. The total buffer time is the scan time buffer milliseconds. And then the timer interval is the total timer interval, which means that buffer milliseconds plus the total scan time. So now let's go look at this read Arduino burst, which gets called every scan, and it's what does the work of grabbing the data and processing it. So here back in the methods, here's our read Arduino burst, and it calls everything else. You can see I've got documentation here, and it's starting with it's defaulting the number of strings I read from the Arduino at 1, and I'm just doing a while loop to grab the data from the Arduino. So while end of data equals false, remember we're waiting for an end from the Arduino to say, okay, there's your burst of data. So while I don't have the end yet, try to read a line from the Arduino serial port. So I'm setting string input string equals Arduino port.read line. So it reads a line. If that was an end string, if input string trim end, so I'm taking out the carriage return line feed at the end of that string, if it was just an end string, then end of data equals true and we're all done. We've got that burst. Else, what we're doing is we're taking each string, each sample string, which is, as we showed here, 0 to 1023 with an RN. If it is not the end of string, we're just adding that to a raw input string list, which we showed before. So it's just adding that input string, and we're just tacking on each sample into this raw input string list. And then what we're going to do, once this is done, once we've got an end, we're going to send that to the input data processor so it can parse it and generate the times and everything else. If it couldn't read data, it's got this is a try, so we're going to have a catch. We're going to have a message box couldn't read data from the Arduino, okay? And if not end of data, just increment the number of strings that we've read and go through and do it again. Now, if we are done, we are going to call the input data processor, but first we need to instantiate a input data processor class, and we're going to call it processor. So processor equals new input data processor, and we're going to feed that raw input string list that we just grabbed from the Arduino. And again, keep in mind, this is happening every scan, this process. And then once we've got that, we're going to say process data burst method. And we're going to call this method below us, which is going to call the methods inside this input data processor. So now it has the input string list in the input data processor, and we're going to go through and we're going to process that data. So now let's take a look at our input data processor class, which is now going to start coming into the picture. So again, I've got my documentation, my to-do list, and I've got some properties. And the properties are, it's got a list of string, which is called input string list, and that again is the values with a carriage return line feed coming from the Arduino. And it's going to convert that into an input integer array of values from 0 to 1023, which represent the voltages. And I've also got another process double array, which when I take this input integer array, we now, as we said before, have to convert it into a double array that has time, comma, value in each element. So it's going to be the time in milliseconds with a 0 to 5 voltage value. And this is going to be the very important double array that we're going to process to get our max and our mins and our averages and our frequencies and everything else. So it's got this process double array that it's holding, and we can also take that process double array and convert it back into a string array so we can send it out to CSV, all right? So these are the main data arrays that are being held by this input data processor, and they're public so anybody can make use of them. So we've got the string array, and then we're going to have a value that we're going to use quite often, which is the burst average. We can go through this double array and calculate the average value of the elements, and we're going to hold it in this burst average. And then we've got some other variables that we're going to use in our get frequency method we'll talk about later, which is start time, end time, and frequency. All right? So we've just got these properties to start off. Then in our constructor, again, we're going to call this input data processor as we instantiate, and we're going to pass it this list of string, which is the data from the Arduino, and we're going to instantiate, or we're going to set up these input integer array, the process double array, the string array, and the input string list. All we've got left is these methods. And the methods are to parse the data into the integer array. We have to scale the values. We got to use the vref. Okay, we're going to feed it a vref and a scale range, and we're going to have to scale those values using that vref. So it's going to be 0 to 1023. We've got to convert those into voltages. And then we have to generate the times for each sample. So we're going to feed it the sample interval in milliseconds, and it's going to go through and calculate the times for each sample. And then we'll talk about in subsequent videos, we can get maximum, we get the average, we can get the AC coupled version of this array, we can get the frequency, and then here we're going to get the CSV out. So let's look at what we do for the parsing the CSV burst. So we've got the list of string, and we're going to default this integer I equals 0. For each string S in the input string list that we got from the Arduino, we're going to first trim the end off each character, the Rn, and that's going to give us a value with 0 to 1023. Then we have to convert that 0 to 1023 into an integer, all right, and make it into an integer array. So if we're going to try parse that value string and put it out into this input integer array, element I. If we can't parse it, we're just going to put in a 0 in that value. So it's going to go through for each input string, it's going to convert that to an integer and add it to the input integer array. and then we're going to increment that and just keep going through. So very simple. Parsing just converts from 0 to 1023 into an actual integer array of those numbers. So now, since we've got the values in an integer array of 0 to 1023 for each value, we have to convert that into something meaningful, which is a double, which is from 0 to 5 volts or whatever. And we're going to use the scale values burst to do that. So we're converting that scale range into a double so we can do some division. The range of 1023 is now a double, and for I equals 0 to the array length, we're going to go through and calculate for each sample what is it in terms of volts instead of 0 to 1023. So our sample double is convert to double this integer array. So we've got the 0 to 1023 value. Now we just need to multiply that times the VREF to get the actual voltage. So our process double array value, 1, because it's a time and voltage, so the first element is the voltage, and that's the VREF times the sample double over the range double. So whatever your actual sample value is in double format, divided by the 1023 times the VREF, and that will give us the actual voltage of each array element. So very straightforward, just go through and convert those 0 to 1023s into a 0 to 5 or whatever volts, and fill out our process double array for that. The other thing we have to do is we have to get the times. We have to calculate the times since we didn't get them from the Arduino. So it's going to take in our sample interval in milliseconds, which remember it's 0.1 milliseconds in default or 0.02 for the high speed. We're going to say sample time equals 0, and then for each element, we're going to calculate a time for each element. So we're going to start at 0 and say process double array I, the 0th element or the time element, equals the sample time. And then each time we go through, we're going to increment the sample time by the sample interval in milliseconds, right? So from the UI, we know what the sample interval in milliseconds is, and then we just increment that and add that to the process double array to get our times for all the values. So now we've got our process double array with the actual times and voltage values. So now all we have to do is plot. Now the rest of this stuff we'll talk about in the future video, where we do the get max, average, AC coupled, frequency, and CSV output. But for now, we've basically got all our values, we just need to plot them. Okay, so now that we have instantiated our input data processor and we know what the input data processor does, we've read the data from the Arduino with this read Arduino burst, and the next thing we do is we call this process data burst method right below it, and this is going to call the processor, the input data processor, and start parsing and converting it to actual values, and it's even going to go out and it's going to plot. So let's take a look at this process data burst. Again, this happens every scan. So first thing, it's going to call the processor and parse the CSV burst, which converts it from a string to an input integer array. The next thing, since we're doing this every scan, we have to update the sample interval in milliseconds. So again, we're going to have, the user is going to be able to adjust the scan duration. So we're going to have to update that every scan. So the sample interval in milliseconds is going to be the burst duration in milliseconds, selected by that scan, plus the number of samples that the user has specified. Now, I've also added in this little fudge factor here. That is for the frequency measurement, which we'll talk about later. You don't really need this unless you're doing the frequency measurement. We'll talk about that in a future video, but basically the sample interval in milliseconds is the burst duration that the user specifies and the number of samples. So we're just going to divide that out to get the sample interval in milliseconds, how many milliseconds per sample. Then we're going to call the input data processor and say, okay, we've got the data 0 the times, and we're going to use that sample interval millisecond, okay? And then we're going to scale the values like we just saw using 1023 for the 0 to 1023, and then vref for whatever the vref is. All right, so now we have zeroed the times, we've done the scale, and we have generated the double array of times and values. This we're going to talk about a little bit later, where we do the AC or DC coupling, where we call the processor and you get AC coupled. And here we'll talk about later where we update the maximum value on the display, the average value, the frequency. But then we're going to go to the plot data burst. We're going to feed it how many samples we want to plot of this process double array, and it's going to go through and plot. And let's go to the plot data burst, and that's the last part of this, and it's very straightforward. We feed it how many samples we want to plot, and then we've got the list of string we talked about before, the X values and Y values. We're going to clear both of those to make sure the list is clear, and then we are going to add each element of the process double array, either the time or the voltage value, and we're going to add each one to each list, and then we are going to plot those using that data bind. So we've got the X values, the list of X values, and the corresponding list of Y values, which is two separate lists of doubles. And now we're going to just plot those using this points.databind and use the X vals and Y vals. Now, since this is on a different thread, we have to use this chart1 invoke this delegate, and that will allow us to access the chart from this thread. So that's it for the core functionality in C# or whatever language you choose. In the next video, we're going to look at some of the additional features. We're going to show you how to trigger. You see this nice solid waveform that's being updated every 0.2 of a second, but it's triggering, so it's starting at the same point, so it's a nice clean waveform. And we'll look at the adding markers, and we're looking at the track bars and some of the other functions, the DC-AC coupling. And anyway, if you like any of these videos, I appreciate it if you hit the like button and subscribe and hit the bell notifications. And most of all, let others know that we're here so we get some more viewers. Otherwise, hope that helps. Take care and have a really good day. Thanks.